To those that are coming back, welcome back. And to those that are new, welcome to my YouTube channel. And thank you for subscribing. And if you haven't subscribed yet, please subscribe. Now, in today's video, we are going to be talking about completing the square on quadratic expressions. When do we complete the square on quadratic expressions? We complete the square on quadratic expressions, especially when we want to draw a graph of a quadratic curve. Now, the graph of a quadratic curve is also known as a parabola. We are going to go in details when we go to graphs and function in another video. Now, for today's lesson, we are only going to focus on completing the square on a quadratic expression, which will in future help us to find the turning point of a quadratic curve. Now, we are going to look at a few examples. After the first example, pause the video and then you try the second example on your own. These are examples of quadratic expressions. Now, the first one, we are given x squared minus 8x plus 3. Now, to complete the square on this, we are actually going to be asked in some instances to write the expression in this form. In the form A, outside the bracket, we have x minus p, close the bracket, squared plus q. However, this sign could have been a plus, it could have been a minus, this sign could have as well changed. This is just the general formula that we are given to actually require us, or which actually requires us to complete the square, so that we are rewriting this expression in this form. And in future, we are going to learn how do we use that form now to establish or decide on what is our turning point. Now, as we complete the square on these examples, we are going to look at a few steps. We don't have to memorize the steps, but rather understand the steps. Now, the very first important step is to make sure that A is 1. So you make sure that A is 1. Now, what is A? We know that when we talk about a quadratic expression or a quadratic equation or a quadratic in general, it's in the form ax squared plus bx plus c. So as we continue looking at the steps and where we speak of A, we are actually talking about the coefficient of x squared. Where we talk of B, we are talking about the coefficient of x. And when we talk about C, we are actually referring to our constant. So going back to our steps, we said we should make sure A is 1. So meaning we want to make sure that the coefficient of x squared is actually 1. And you might find that in the expression that is provided or that is given to you, A is already 1. And when that is the case, it just actually means that your first step is already ticked off. So you just have to go to your next step. So if you look at the first example, for instance here, when there is no coefficient, we all know that it's supposed to be 1. So that means our A is already 1 in our first example. So we go to the next step and we will learn what do we do when A is not 1. Because definitely we will have to make it 1. And we will be taught in the third and fourth example as to how do we make it 1 when it's not 1. Now, so first step ticked for the first example. We go to the next step. The next step, step number 2, is to find b over 2 squared. So find b over 2 squared. We do not remove this square. We are calling this process completion of the square, as much as it's not what we have titled it there. We know that for us to express our expression in this form, we are actually going to only be able to do that by completing the square. So now the process that we are busy with is called completion of the square for a purpose. So we need to keep it in brackets. We can simplify the inside part of the bracket, but we don't remove the brackets. We don't remove the square, so that it can complete the square that we already have, the part of the square that we already have. Now, so we are going to find our b over 2, and whatever I'm writing in blue is specifically for the first example. So in this case, we have to identify our b, and our b is actually negative 8. But for the purpose of this video and for your future, for safety, we are not going to carry the negative as much as we're supposed to, but we know that if we say negative 8 over 2 and we square it, the moment we square this, we are going to get the same outcome as when we don't square it. And we are not going to carry this negative because I have seen in the past that it confuses some of my students. So there's nothing wrong with you not carrying it. You're still going to get the correct answer and you're going to be safe with your signs. Now, so we are going to find our b over 2 squared. That is what we are actually trying to find here. We can simplify the inside part, I repeat that, but we don't need to remove the brackets. So we are going to remove, actually simplify 8 divided by 2, and that is going to give us 4, and we keep it as 4 squared. Don't use 16, which is the answer to 4 squared. We keep it as 4 squared. So after finding our A, or after making sure that A is 1, and after finding our B over 2 squared and not solving, not removing the brackets, not removing the square, we simplify the inside part. That takes us to the third step. Now the third step, go and add B over 2 squared after the bx term. What do I mean by that? I mean the following. So we are going to go and apply the 2 steps. We have found our B over 2 squared and we've simplified it, right? So now that takes us to the third step. So the third step is saying we are going to write, excuse me. The third step is saying we are going to write the first term as it is. We are going to write our second term as it is. Our second term as it is. And we are going, or we are told to add our B over 2 that we have found in the second step. We now add it after the bx term. Which one is our bx term in this case? This one. So we now have to add it. So we are going to add our B over 2, which is our 4 squared. And then we continue with our C term. And then that also complete the third step. So after adding it, we then, fourth step, we then subtract the B over 2 that we found squared from C. So we are now going to subtract our B over 2 term. So we are going to subtract it. So now after we added our B over 2 terms, our B over 2 squared term after the bx term, and we continued with our C and we subtracted. So to recap, remember as I'm recapping, I'm helping you get to know your steps. Make sure A is 1. If it's not 1, we're going to learn what we do to make it 1. We make sure that we find our B over 2 squared, and we do not solve the square. We don't remove the square. We simplify the inside part. We're allowed to do that. But we don't remove the square. After finding it, we add it after the bx term, and we subtract it from the C term. What we are trying to do here is actually nothing but making it possible for our completion of the square. Why am I saying nothing? Because I mean, if you add, you have one thing. If you add something and at some point you subtract it, you actually didn't do anything. You simply, whatever you added, you subtracted it. So basically that is making it possible for you to then complete the square. It's only making it possible for your completion of the square, but it's not changing the value of your expression. Now, to continue, the next step is to factorize. So we are going to factorize step 5. We are going to factorize. So how do we factorize? We are now going to factorize the first 3 terms. The first 3 terms, and solve the last 2 terms. So that one you can take note of it. Factorize the first 3 terms and we simplify or get the answer to the last 2 terms. So that you can write on your own. But so what are we doing here? To factorize, it means to insert brackets. Factorization is the opposite of expand, right? So we are going to open our brackets because that is what it means to factorize. And we are always going to take the base from that first term. This is how we factorize in completion of the square. We open the bracket, we copy our base from the previous step, only the base for the first term. On the second term, we are only taking the sign. We are only taking the sign from the second term, and we are going to put minus. And from the third term, we are only taking the base. So basically, we are going to take what is squared, the 2 things that are squared. This part of the square is completed by, or we are using the other part of the square to complete this part of the square. So, but what we're doing is we are actually going to take the base from here, the sign from here, and here we are going to just write down the base, and together we close the bracket, and together what we have, the bases we chose together, they were squared. So we put our square there. Then we are going to solve this, and we press it on our calculator, and 3 minus 16 is actually negative 13. So we have negative 13 there. And we are done. We basically expressed this quadratic in the form x minus our b squared plus our q, which is negative in this case. So, and you should not be worried about the signs. You should be content with knowing your steps, and you should trust yourself as long as you are right. And if you remove this back, you're going to see that it will simplify back exactly to what is given there. And this is still this, just in another form. Just in the form that will help us in future to find the turning point of this quadratic curve. Because this equation, when we make it a function and say y equal to that, that function is actually going to be a curve which will look like this graph, either opening up or maybe opening down, depending on the value of a. But I don't want to bore you with that yet. We are going to have a separate video for drawing these quadratic curves. But I want, as you go there, or for us when we reach that part, we already know how to complete the square, which will in future help us to find what is the turning point of this graph. We are going to get that information from here. I don't want to go there yet, but we will do a video on that. So that is the first example. So now we are going to do the second example. I'm going to, because I need this space, so I'm going to get rid of the steps, but I hope you have written down your steps. But before I do it, try to pause the video, and then you try to do it on your own, and then you come and continue the video to see if you are right or not. Remember your steps. Make sure a is 1. If it's not 1, we are going to learn how we make it 1. Second step is to find your b over 2 squared. We don't remove the square, we don't square that b over 2. We can simplify the b over 2, but we don't remove the square, we keep it squared. Third step is actually to add our b over 2 after the bx term. So we have ax squared plus bx plus c. So after the bx term, we add our b over 2 that we have found, a simplified version. And then we continue with c, and then we subtract it. So what we did is nothing, I'm emphasizing on that, but we just made it possible for the completion of the square without changing the value of the expression that is given to you. Okay, we already included the third and the fourth step. So the last step is to factorize the 3 first term of your expression, and then you solve the last 2. Okay, so that takes us to example B. So what is the first step? Make sure it's 1, and indeed a is 1, right? Then we need to find our b over 2. Remember, we don't carry the sign. And just before we continue, let me take you back a little bit. We didn't want to carry that negative sign, because if we carried it here and we kept it here, some of you, when you come and copy the base, you will, which would have been the right thing, you will copy the sign with making this minus and negative, changing it to plus while it's supposed to be minus, making it wrong. So to avoid that confusion, you simply take the sign from there. You don't come and carry that sign anymore. You have ignored it when you found your b over 2, which is safer, and then you're safe. So now we have made sure a is 1. Back to the example B, we have made sure a is 1. Now we need to find our b over 2. So let's find b over 2 for this. So what is our b over 2 here? Our b is 7 over 2 is just going to be 7 over 2. Since 2 does not go exactly into 7 without leaving a reminder, so we are going to just keep it as 7 over 2.